Imagine a galaxy so massive that if you placed it where the Milky Way is, it would swallow up every galaxy in our entire local group. Andromeda, Triangulum, the Magellanic Clouds, all of it. Like they were grains of sand disappearing into an endless cosmic ocean. Well, that's not science fiction, that's reality. Galaxies come in all sizes, from tiny dwarf galaxies to absolutely colossal supergiant ellipticals that defy our ability to even comprehend their scale. And today, we're counting down at the 10 biggest galaxies we've ever discovered in the universe. But here's the wild part. Even astronomers are still debating which one actually deserves the top spot, because measuring something this enormous is harder than you think. So, if you want to find out which cosmic titan takes the crown, stick around until the very end. Starting our countdown at number 10, we have NGC 262, also known as the Fomalhaut galaxy because of its location near the bright star Fomalhaut in the constellation Pisces. Located about 200 million light-years away from us, this lenticular galaxy is a cosmic behemoth. NGC 262 measures approximately 1.3 million light-years in diameter. To put that another way, you could line up 13 Milky Way galaxies, end to end, and still not match the width of NGC 262. This galaxy is so huge that if it were placed where the Milky Way currently sits, its outer edges would extend far beyond the orbit of Andromeda, our nearest large galactic neighbour. What's really fascinating about NGC 262 is that it's not alone. It's the dominant member of a small group of galaxies, and its massive gravitational pull is slowly drawing its companions closer. We're witnessing cosmic cannibalism in action. The galaxy is ancient, literally. Most of its stars formed over 10 billion years ago, making it older than our Sun by more than twice its age. NGC 262 is in its retirement years, having burned through most of its star-forming fuel. It's now a gentle giant, slowly growing by absorbing smaller galaxies that wander too close. For now, it remains one of the most visually striking lenticular galaxies in the entire observable universe, a testament to the incredible scales that gravity can build over cosmic time. At number 9, we have NGC 4889, one of the most massive galaxies in the nearby universe. You might recognize this name from discussions about supermassive black holes, because NGC 4889 hosts one of the largest black holes ever discovered. But the galaxy itself is far more extraordinary than even its monstrous core. NGC 4889 sits in the Coma cluster about 300 million light-years away from us. This elliptical supergiant has been measured at approximately 1.3 million light-years in diameter, making it absolutely massive. But here's where NGC 4889 becomes really exciting. It's not just big, it's incredibly dense with stars near its core. The central region contains hundreds of billions of stars packed so tightly that if you lived on a planet there, your night sky would be blindingly bright with neighbouring stars. Some scientists estimate that planets in that region would never experience true darkness. Imagine that. A world where the night sky glows like perpetual twilight because stars are everywhere you look. NGC 4889 is also home to one of the universe's most extreme objects. Its central supermassive black hole weighs in at about 21 billion times the mass of our Sun. That's a black hole so massive that its event horizon, the point of no return, is larger than our entire solar system. When NGC 4889 does eventually consume another galaxy, and it will probably within the next few 100 million years, the collision will be one of the most energetic events in this region of space. That's something to think about. A galaxy you can observe with powerful telescopes right now is destined for a violent cosmic merger that will reshape it completely. Number 8 is Hercules A, one of the most mysterious and unusual galaxies we're counting down today. Located in the constellation Hercules, approximately 2 billion light-years away, Hercules A is classified as a giant elliptical galaxy, one of the brightest radio sources in the entire sky. This galaxy measures roughly 1.5 million light-years in diameter. That's bigger than NGC 4889. But what makes Hercules a truly extraordinary is what's happening at its core. The supermassive black hole at the center of Hercules A isn't just sitting there quietly. It's actively feeding, devouring matter at an incredible rate, and blasting out enormous jets of energy that extend for millions of light-years into space. These jets are so powerful that they're creating massive bubbles of superheated gas in the space surrounding the galaxy. We're talking about energy output that dwarfs anything our Milky Way has ever produced. What fascinates astronomers most is that Hercules A appears calm and peaceful in visible light, looking like any other elderly elliptical galaxy. But when you look at it with radio telescopes, it transforms into a cosmic monster, with energy jets stretching across distances so vast they beg a belief. It's cosmic horror and beauty all rolled into one. We're talking about a galaxy so enormous that its influence extends far beyond its visible boundaries, shaping the structure of space itself across millions of light-years. Moving into the top 7, we arrive at ESO 306-17, a galaxy so incredibly huge that it sits within one of the most distant galaxy clusters we can observe clearly. Located about 500 million light-years away in the constellation Centaurus, ESO 306-17 is estimated to be around 2 million light-years in diameter. This is an elliptical supergiant that exists in one of the most densely populated cosmic neighborhoods we've ever found. The entire cluster is packed with hundreds of massive galaxies, and ESO 306-17 is one of the crown jewels, sitting right at the center of the cluster like a cosmic queen surrounded by her court. Here's what makes this galaxy stand out. It's not just massive, it's also incredibly luminous. The galaxy shines with the light of hundreds of trillions of stars, making it one of the brightest objects in its region of the universe. ESO 306-17 is also a galactic graveyard. The stars within it are ancient, formed during the early epochs of the universe when star formation was at its peak. Now, the galaxy is slowly fading, its stars burning out one by one over timescales we can barely comprehend. Some estimates suggest that ESO 306-17 is losing the equivalent of several solar systems worth of material every century as old stars die and their remnants are cast into space. The galaxy is heading inevitably toward a slow, quiet death. But that's still trillions of years away. Some scientists even think it might merge with other cluster members before it fades completely, growing even larger in one final cosmic embrace. For now, ESO 306-17 stands as a monument to the incredible power of gravity to build structures on scales that dwarf human comprehension. At number 6, we have a 2261-b CG, a brightest cluster galaxy lurking in the able 2261 cluster about 3 billion light-years from Earth. This galaxy is often overlooked in discussions about galactic giants, but it absolutely deserves to be here. A 2261-b CG is thought to measure around 2 million light-years in diameter, though some measurements suggest it could be even larger. Like many of the giants on this list, it's an elliptical galaxy that's already well into its old age. But here's what I always say. BCG, truly remarkable. This galaxy has a mystery at its heart. literally. Astronomers expected to find a supermassive black hole at its center, as all large galaxies should have one. But when they looked, they couldn't find it. The black hole that should be there, possibly weighing tens of billions of solar masses, seems to be missing. The leading theory is mind-bending. Scientists think that A2261-BCG might have ejected its central black hole during a galactic merger. When two galaxies with supermassive black holes collide, the black holes can merge and release so much energy in the form of gravitational waves that they literally kick themselves out of the galaxy. We're talking about an object billions of times more massive than the Sun being ejected into intergalactic space, like a cosmic bullet. What's remarkable about A2261-BCG is its implications. If we're right about the missing black hole, it means somewhere out in the darkness between galaxies, there's a wandering supermassive black hole, invisible and dangerous, drifting through the void. Despite being so enormous, it's too far away and too diffuse to see without powerful telescopes. Yet, if it were as close to Earth as Andromeda, it would dominate a huge portion of our night sky, appearing as a ghostly elliptical glow, dozens of times larger than the full moon. At number 5, we enter truly extreme territory with IC 1101, one of the most famous supergiant galaxies ever discovered. Located at the center of the Abell 2029 galaxy cluster, approximately 1 billion light-years away, IC 1101 has long held the title of largest known galaxy in popular astronomy circles. This monster measures approximately 4 to 6 million light-years in diameter, depending on where you define its outer boundary. IC 1101 is so massive that it contains an estimated 100 trillion stars. To put that in perspective, that's roughly 1,000 times more stars than our Milky Way. If you could somehow count one star per second, it would take you over 3 million years just to count all the stars in IC 1101. The galaxy's mass is equally staggering, weighing in at about 100 trillion times the mass of our Sun. What makes IC 1101 so enormous? It's a cosmic cannibal that has spent billions of years consuming everything around it. Sitting at the gravitational center of its cluster, IC 1101 has devoured dozens, perhaps hundreds of smaller galaxies over its lifetime, each merger added to its mass, spreading its stars out over ever larger volumes of space until it reached the mind-boggling size we observe today. But here's the eerie part. Despite containing 100 trillion stars, IC 1101 is incredibly dim for its size. The galaxy is so spread out that in many regions, stars are separated by vast distances, sometimes millions of miles apart. If you lived in the outer regions of IC 1101, your night sky might be nearly empty, with only a handful of visible stars, despite being inside one of the largest galaxies in the universe. It's a cosmic paradox, a galaxy so big it's nearly empty. MIC 1101 represents the endpoint of galactic evolution. It's a retired giant, having consumed most of its neighbors and burned through most of its gas for making new stars. Now it just sits there, slowly aging, a monument to billions of years of cosmic violence and growth. At number 4, we have Alcyonius, and this is where things get truly wild. Discovered only recently in 2022, Alcyonius is a radio galaxy located about 3 billion light-years away in the constellation Lynx. The galaxy itself measures roughly 16.3 million light-years across, when you include its massive radio lobes. Yes, you read that right. 16 million light-years. To put this in perspective, Alcyonius is so large that if you placed it where the Milky Way is, it would extend past Andromeda, past Triangulum, past every galaxy in our local group, and well beyond. It would span a significant fraction of the distance to the Virgo cluster, our nearest major galaxy cluster. We're talking about a structure so vast that light takes 16 million years to cross from one end to the other. But here's the catch. When we talk about Alcyoneus being 16 million light-years across, we're not just talking about stars. The galaxy's stellar component is probably only a few 100,000 light-years across, comparable to other large ellipticals. What makes Alcyoneus special are its radio jets, enormous streams of energetic particles being blasted out from the supermassive black hole at its center. These jets have been active for hundreds of millions of years, continuously pumping energy into the space around the galaxy and creating gigantic lobes of radio-emitting plasma. The lobes are so enormous that they dwarf the galaxy itself by a factor of more than 20. It's like a tiny engine producing an exhaust trail that's vastly larger than the vehicle creating it. What fascinates scientists most is that Alcyoneus isn't even particularly special in terms of its black hole mass or radio power. It's a fairly ordinary radio galaxy that just happens to have grown to extraordinary size. This suggests that given enough time and the right conditions, many radio galaxies could potentially grow this large. Alcyoneus might not be unique, it might just be the first one we've noticed. The discovery of Alcyoneus has forced astronomers to reconsider what we know about the limits of galactic growth. If structures this large can form, what else might be lurking out there in the cosmos, waiting to be discovered? Climbing to number 3, we have the central galaxy of the Phoenix Cluster, a cosmic monster that breaks several records simultaneously. Located about 5.7 billion light-years away in the constellation Phoenix, this galaxy sits at the heart of one of the most massive galaxy clusters ever discovered. The galaxy itself is estimated to span approximately 2.2 million light-years in stellar diameter, but like Alcyoneus, its sphere of influence extends much further. What makes the Phoenix Cluster's central galaxy truly extraordinary is not just its size, but what's happening inside it. This galaxy is undergoing a starburst event, forming new stars at a rate of about 500 to 800 solar masses per year. To put that in perspective, our Milky Way forms about 1 solar mass worth of new stars per year. The Phoenix Cluster galaxy is forming stars at a rate that would create an entire Milky Way's worth of stars every few 100 million years. This shouldn't be possible. Galaxies this large and this old aren't supposed to be forming stars at all, let alone at rates that would make even young spiral galaxies jealous. The prevailing theory is that the central supermassive black hole is less active than expected, allowing massive amounts of cool gas to fall into the galaxy's core where it can collapse and form new stars. It's like watching a retired giant suddenly spring back to life with renewed vigor. The galaxy is also incredibly hot. The hot gas surrounding it reaches temperatures of hundreds of millions of degrees, making it one of the most extreme environments in the known universe. This superheated gas glows brilliantly in X-rays, creating a corona around the galaxy that extends for millions of light years. What's really mind-bending is that despite being billions of light years away, the Phoenix Cluster is so massive and so bright that it affects our measurements of the cosmic microwave background, the afterglow of the Big Bang itself. This single galaxy cluster is so enormous that it leaves a shadow in the very fabric of the early universe's light. That's something to think about. An object so far away it existed when the universe was less than half its current age, and yet so massive we can detect its influence on the cosmos itself. At number 2, we have something truly special, the galaxy cluster Abell 2029's central galaxy, though it's sometimes confused with other giants in discussions. This elliptical supergiant, located about 1.07 billion light-years away, measures an astounding 5.6 million light-years in diameter in some measurements, though estimates vary wildly depending on where astronomers draw the boundary. What makes this galaxy stand out is its sheer dominance over its environment.